Good morning students, welcome back to the session on fluid power laboratory. So in this session we will see about your programmable logic controllers. So here you can see the programmable logic controller. Here you can see GU Fanuc Versa Pro, Versa Max model PLC we are having. On one side of a PLC you will be having inputs, the other side you are having your output, and we have a cable that will be connecting, communication cable that will be connecting with your computer. From there you will be doing the program and then downloading the program to the PLC and then you will be executing. Okay, we have a simple wiring connection. We have a 24 volt DC for input supply. We have that is connected positive, then 24 volt DC negative. Those things are connected. Positive to positive, negative to negative. Then similarly output also we have a positive to positive and negative to negative. These connections are given. And relay outputs also positive to positive, negative to negative given. So here you can see the inputs wiring that is given. Switches are there one by one, input switches. Then we have your input switches 1, 2, like that it is there. Whatever the switch you can connect here. Then you have your output that is connected. First to start with, we will see a simple programming that will be using the software Versa Pro. We will be using the software that what we will be using is your Versa Pro. So once you open the screen, you will be getting like this. Normally you have to going for a new file you will go, but instead of that here you have to go for new folder. So go to your new folder and start your programming. So once you have opened, you will be getting a screen. Maybe one more screen is open already. Okay, that I will close and then I will start it again. So now I have opened new folder. I am opening any new folder I can open. So then I will be getting all the options available for programming. So here I will explain those different symbols. Please, the video stop.
Continue.
So now we can see the different symbols that is used for programming. You can see a arrow mark, a black color arrow mark, the cursor. Okay, for coming out of that various symbols you can make use of that. For example, you have selected this first switch. If you want to come out of this, you can make use of this as a escape button. You can use it, this arrow mark. Here we have various symbols. That is you will be having two symbols for input, normally open contact and normally closed contact, and you have a output, you have one symbol, normally open coil. So for example, this normally open contact is like your switches what you are using. For example, lights and fans, if you put that switch you will be getting the output, that is your normally open contact. Whereas this normally closed contact, it is like your emergency stop button. So once you press that, you will not be getting an output and the machine or output will be switched off. Okay, these are all the basic things you will be using. So normally you will be connecting your input as the first element and then output as the last element. We will not be connecting any element after output. Similarly, we will not be connecting your output as a first element also. So this diagram resembles a ladder. Okay, you will be having two vertical lines. You can see one vertical line here, another vertical line, and you will be having number of horizontal lines. We will be using it for doing the program. That is the reason it is called as your ladder programming. So here you can see a number of other methods of programming also available. Like ladder, we have other methods also. Okay, that we will see in bottle filling Siemens PLC. There I will show you what are the different other methods available for programming. First I will put a simple input. So I am putting a simple input, and then so once for input I will be making use of the symbol I, 1I, first input. Then for output I will be making use of your 1Q. So output I will be making use of 1Q. So once it is over, you have to connect your PLC. So the communication will be established between your system and then your PLC. Once it is connected, so you will be verifying. You can verify your program whether any error is there. After that you can download. Here two options you can see, one is store, another one is load. For example, in Siemens PLC you will be having an option like upload and download. For example, in the computer symbol you can see the program goes from the computer to PLC. Here load, the program comes from the PLC to computer. We have the program in computer, we have to make it pass it to your PLC. We have to make use of the first option. So PLC is in run mode, so you have to stop it, then only you can do it. For example, here you can see the PLC run mode, stop mode. You will be having those options here also, and as the buttons also available here also. This triangle points to your running your PLC. This square button stops your PLC. You stop your PLC every time you are doing programming and downloading. Now you store your program. So once it is stored, now you can run. So you have run your program. What happens? So when you press the first switch, you will be getting your output that you can see in the simulator as well as your real time. So if you press the first switch, the normally open contact, you will be getting my output coil. Okay. Here in the simulator also you can see my input is on with a red color, you can note it, and output is also on. So with a bracket. Okay. Your output is represented by your parenthesis or coil. This is the symbol you will be making use of it. Similarly, we will do some basic logic gates one by one. So if I add one more input here, automatically it becomes AND gate. So now it becomes a AND gate. Only when both the inputs are pressed, you will be getting your output. So I am going to stop the program, stop the PLC, then storing. Once the program is stored, I am running. Now if I press only both the buttons, both the inputs are on, I will be getting my output. Okay, this is my AND gate. Same thing I can do it in my opposite OR gate also. NOT gate, XOR gate, all those things I can do. For example, in the case of your OR gate, so this I have to place it parallelly. Instead of connecting it series, I have to place it parallelly. So now if I press any one of the input, the output will be on. So I am stopping the program and I am storing. Store to PLC completed. Now I am making use of the run button. So once the run button is pressed, so if I press switch 1, I will get output since it is OR gate. If I press switch 2, then also I will be getting the output. Both are on also, I will get output. If any one is on also, I will get output. This is my OR gate. So your NOT gate is very simple. I have to make use of only a closed contact, that's all. That will make my NOT gate. Okay. So if there is no input, I will get the output. If there is an input, I will not get output. That is my NOT gate. So storing done. Then you can see there is no input, I have output. Suppose I give input, I will not be getting any output. This is my NOT gate. Suppose for example, if you want to do after doing AND and OR, if you want to do NAND and NOR, you have to make two changes. Okay, that one change you will be knowing. If you have made use of a open contact, you have to make use of a closed contact. For AND gate, you have connected in series, whereas NON gate you have to connect it parallelly. For OR gate you have connected parallelly, for NOR gate you have to connect it series. That is the difference. For example, now I can see NOR gate. These two changes we have to make. Then store your program. So I have not given the address, that is the reason it is telling not stored. Store. So once it is stored, we have to run. Now I can see, so it is an OR gate. You write the truth table of the NOR gate and then you verify it. There is no input, you can see the output. If there is an input, you will not get the output. Okay, that is your NOR gate. Next we will move to your NAND gate. So stop your PLC whenever you are doing the programming or downloading. Then NAND gate, suppose you want a horizontal or vertical line, you click this letter like inverted T and connect it. If you want a horizontal line, you use it. So similarly I have to give 2i for my input. All this percentage and symbol system will take automatically. So now store your program, then run. Now you can see, so if there is no input, I am getting the output. Suppose if I give an input, okay, still the output will be there, NAND gate. Okay, so AND gate, you know, only when both the inputs are on you will get output, whereas NAND gate it is opposite. Any one of the input is on, you will get the output. So even though both the inputs are 0 also, you will get output, but both the inputs are on, you will not get output. That is your NAND gate. Next you will see one last gate, that is your XOR gate. So here 1i, 2i, again 1i, 2i, so now I can see first line I have a normally closed contact and open contact. Second line opposite, open contact and then closed contact. So here what is the logic of your NOR gate is, it behaves like a OR gate except for your last situation both the inputs are on or both the inputs are off. There it differs, otherwise it will be like a OR gate. So you can see when both the inputs are on, so when both the inputs are on, OR gate will be getting output, whereas in this case you will not be getting. When both the inputs are off also, you will not be getting. So it will be behaving like your OR gate except for the situation both the inputs are on or both the inputs are off. Okay, so their OR gate also both the inputs are off, we will not be getting an output. Now you can see any one is on, you will be getting on, another one is on, also you will be getting on, but both are on, you will not be getting. That is the difference, exclusive OR gate. So now one we will see motor starting circuit, that we will keep it as last for this basic PLC programming. So now what I have done in this program is, first I have an input normally open, second one I have a input normally closed, then I have a output 1Q. Okay, this is my start switch for the motor starting circuit or latching circuit. Once I press this switch, my motor will run. Suppose I want to stop the switch, so stop the motor, I have to press the second switch. So even though I stop my first switch, still my motor will run because I have taken my input from second line and I have given it to the output. The output address Q, I have given it as input here. Because of that, after starting, if we switch off also, still it will run. So if I want to stop, I have to make use of this middle switch, stop switch. This is your motor starting circuit or latching circuit. So now you can see, so I will start. Once I press the start switch, I will be getting the output. Even in the screen you can see. So once I press the start switch, I will be getting the output. So if I stop the switch also, I will be still getting the output. You can see from where I are getting, from second line I am getting the input and then going. So the second line address and first line address both are same, 1Q, 1Q. Only thing here it is connected as input, here it is connected as output. Suppose I want to stop the circuit, I have to make use of my second switch. This is my latching circuit or motor starting circuit. So this is about your basics of PLC. So here in this we have discussed about normal operation of your input output, PLC ladder programming, logic gates and motor latching circuits. All those things we have done. So in the next two exercises we will see about your timer and counter in one exercise, and then automatic actuation of a double acting cylinder using solenoid in another exercise. Thank you.